This is a review for geometry, chapter 16. You are not required to fill this out. Years past we have, we're not doing it this year, but I will use this picture up here to help me answer the questions below. First question, what's sine of 90 degrees? Well, if I go here to 90 degrees, I need to know what x, y, and r are. X would be 0. Y, you could choose any number that you want to choose. I'm going to choose 1, and that's going to lock in the radius as being 1. Sine is y over r. That's 1 over 1, which is 1. Cosine of 120, that's going to fall here into quadrant 2. So I want to make sure that I make a reference triangle for this. It's going to make the reference angle 60 degrees. Opposite 30, negative 1. Opposite 60, square root of 3. And the radius is going to be 2. So what's cosine of 120? That's x over r, so that's a negative 1 over 2. Tangent of 45, that's in quadrant 1. Going to make a reference triangle. And a 45, 45, 90. Both legs are 1 and the hypotenuse is square root of 3. I'm sorry, square root of 2. Tangent is y over x. That's 1 over 1, which is 1. Question 12, tangent of 120. I already have that picture drawn here. Tangent is y over x. That's negative 1 over square root of 3. If I rationalize this, I get negative square root of 3 over 3. Cosine of 225, that's in quadrant 3. That makes the reference angle here 45 degrees. So x is going to be negative 1, y is going to be negative 1, and r is going to be the square root of 2. So cosine is x over r. That's negative 1 over the square root of 2. If you rationalize this, you get negative square root of 2 over 2. Sine of 135, that's going to be here in quadrant 2. It makes the reference angle 45 degrees. If that's 45 degrees, then both of the legs are going to be 1, with the x1 being negative because we're going left. And the hypotenuse is square root of 2. Sine is y over r. If you rationalize it, you're going to get square root of 2 over 2. 330 degrees, that is down here in quadrant 4. Makes the reference angle 30. So opposite 30, I'm going to call 1, negative because we're going down. Opposite 60 is going to be the square root of 3. It's positive, we went right. The hypotenuse is 2. Sine is y over r, so it's negative 1/2. Tangent of 315, that's going to make this triangle here a 45, 45, 90. It's better if you can just redraw these triangles. I'm being super lazy. So each of these legs here are going to be 1 and negative 1. Y is negative because you went down. Radius is square root of 2. Tangent is y over x, which reduces to negative 1. Cosine of 240, it's here in quadrant 3. Makes the reference angle 60 degrees. Opposite of 30 is 1, negative because we went left. Opposite 60 is the square root of 3, negative because we went down. This makes the radius 2. Cosine is x over r, so that's negative 1/2. 18, 225 negative. 225 negative is going to put us at 135 positive. That's going to make a 45, 45, 90. The legs are going to be 1 and -1, and the hypotenuse is square root of 2. Sine is y over r. That rationalizes to square root of 2 over 2. Cosine of -240 is going to put us at 120 positive. That makes the reference angle for this 60. (30, 60, 90). Opposite 30 is -1. Opposite 60, square root of 3. And the radius is 2. Cosine is x over r, so that makes that -1/2. Tangent of -300. -300 is going to put us over here at a positive 60. If you make a reference triangle, it's a 30, 60, 90. Opposite 30 is 1, opposite 60, square root of 3, opposite 90 is 2. Tangent of -300 is y over x, which is the square root of 3. 39 through 44, I said we weren't going to do those, so I will uphold my promise. Number 9, state the quadrant in which the terminal side lies. For this, you can go round and round and round, or you can find a coterminal angle between 0 and 360. That's what I'm going to do. I'm going to add to this a complete revolution, and that's going to give me -86 degrees. That's not between 0 and 180, but that makes this pretty easy to find. But if we go in the negative direction, we won't make it to the negative y-axis. So we would say this is going to terminate in quadrant 4. 870, I'm going to subtract 2 revolutions from this. That's 360 times 2 to get 150. 150 is going to terminate between 90 and 180, which is going to happen in quadrant 2. -190, if I go in the negative direction, it's going to go past -90, past -180, and into quadrant 2 to get -190. So that is quadrant 2. Number 12, 215. We got 0, 90, 180, 270. 215 is going to fall between 180 and 270, so that's going to fall in quadrant 3. Number 13, find one positive and one negative coterminal angle. So we got to find a positive coterminal angle and a negative, coterminal angle. And now I will do the same for this next one. Coterminal angles are complete revolutions apart. So if I take 30 degrees and add a complete revolution, I'm going to get 390 degrees. If I take 30 degrees and subtract a complete revolution, I get -330 degrees. There are many correct answers for these. Those are 2 sample answers. -720, or I'm sorry, -705. I'm going to add 2 revolutions to this, which is 720. That's going to give me a positive angle of 15 degrees. If I just add to this 1 revolution, that's going to put me at -345 degrees, which is a negative coterminal angle. 14 also has an infinite number of correct answers. 23, convert each radian measure to degrees. So I got -5 pi over 9. We're going to multiply it by 180 degrees over pi radians. Pi's cancel. I mean, this one technically has radians as well. Those cancel. 9 goes into itself once, goes into 180 degrees, 20 degrees times. That makes this -100 degrees. 24, if we multiply this by 180 degrees over pi, pi's cancel. 6 goes into itself once, goes into 180 degrees 30 times. So this is going to be 150 degrees. Number 25, if you multiply this by 180 degrees over pi, Pi's cancel. 36 goes into itself once, goes into 180 degrees 5 degree times. So we get 23 times 5, which is 115 degrees. 26, if you multiply this by 180 degrees over pi, pi's cancel. 18 goes into itself once, goes into 180 degrees 10 times. So that's going to make this 790 degrees. 11 through 14, draw the reference angle, find the exact value of the trig function for theta. Well, sine of theta for 6, 8. 6, 8 is going to fall into quadrant 1. X is 6, y is 8. That's going to make R 10. This is a 6, 8, 10 Pythagorean triple. Sine of theta is y over r, y is 8, and r is 10. Don't need to simplify it. Number 12, square root of 3, negative 1, that's going to fall into quadrant 4. Make a reference triangle. So x is square root of 3, y is negative 1. This is a special right triangle. It's a 30, 60, 90. If you didn't recognize that, use the Pythagorean theorem, you'd figure out that r was 2. Cosine of theta is x over r, so that's square root of 3 over 2. Number 13, this is in quadrant 3. X is negative 15, y is negative 5. We don't have to figure out what r is for this because tangent is y over x. That's negative 5 over negative 15. Reduce that if you want. It's really not necessary. Number 14, this is in quadrant 2. We're going left 2. We're going up 2 square roots of 3. If we use the Pythagorean theorem, x squared plus y squared is r squared. X is negative 2. Y is 2 square roots of 3. We don't know what r is. Negative 2 squared is 4. 2 square roots of 3 squared. 2 squared is 4. Square root of 3 squared is 3. 4 times 3 is 12. That's going to make r plus or minus 4. R is always positive, so it's positive 4. Therefore, sine of theta, which is y over r, is 2 square roots of 3 over 4. And you could reduce that if you wanted and get square root of 3 over 2. All right, that concludes the review. Test tomorrow.